Yes, good morning, and thank you. I'm not going to talk about me, but here's a little write-up somebody did. But let's do the introduction and what it's all about. Basically, we're going to be talking about 192, 195. We're going to talk primarily 1160, API 1160, and the new 1185. And then also we'll be talking about ASME B31.8, subpart O, and things of that nature. And then also the AMP NACE new document on integrity management that just came out 0113. So hang on to your hat. This is a great subject, and it keeps evolving as everybody could see. But the bottom line is, it's just not the regulations, but what operators need to be doing: preventing third-party damage, controlling corrosion, detecting unattended releases, minimizing the consequences of unattended releases, and of course, operating pressure reduction plays a big role, particularly when we're dealing with cracking and other issues. As I said, what the learning objective was, we'll be talking about that and the new documents and things of that nature. So let's get started. Like I said, the course agenda would be 192. We'll be talking about corrosion testing, operations, integrity, and then on the 192 side, and then 195 would be O&M and corrosion. O&M doesn't have their own subpart. Did anybody ever wonder why? Because they speak with one voice. We're on the gas side, multiple voices, AGA, INGA, and so on and so forth, GTI and so forth, Southern Gas. We have a lot of voices. And then the industry standards we'll be talking about is the 1160 primarily, but the 1173's come out, and that's management, primarily pipeline management. And then also we have the new 1185, like I said, the public engagement, and then the B31.8 and so on and so forth. And primarily, we're going to be talking about the NACE documents too, and how they just started integrating their new integrity management program, the standard practice that has come out. So let's talk about 192, requirements for corrosion control. It's been around for ages, since 1971. And so it hasn't changed that much, but there has been changes over the years. But the biggest thing that has changed probably is the examination of buried pipe when exposed. And of course, it has the protective coatings in there that we should be thinking about: CP, external monitoring, electrical isolation test stations, and interference, particularly today in today's world of AC interference that has been added in there. And then we need to think about some of the other requirements for corrosion control, i.e. internal. Once it's been established that there's a corrosive environment, you need to be taking care of that. Of course, atmospheric issues, general, and atmospheric corrosion and monitoring, remedial measures, and then DA, direct assessment for EC, that's external, internal, and SCC. And of course, records and inline inspection of pipelines. And we'll get into that a little bit later. As far as the regulations go for 192, and I'll get to 195, so hang on, guys and ladies, prescribes the minimum requirements for the operation of the pipeline facilities. Of course, we should have written procedures, which the O&M, and also emergency response. And what's that about? Well, we're talking about not just any kind of an abnormal operation, and then that includes unintended closure of valves. It happens. Sometimes things happen because of the multiple pipeline right-of-way systems and things of this nature, and temperature swings, and things go wrong sometimes, and you have to go out and look and see where those valves closed if you don't have any kind of SCADA systems on them. We need to look at O&M and like I said, the emergencies and the verification of the pipeline, the material properties. Since the mega rule has taken place, right? We need to be doing more non or destructive tests, examinations to verify material properties. Destructive, of course, would be hydro and in that regards. And of course, the biggest thing is TVC, documentation and verification of material properties. That includes the toughness and then the sampling. And the sampling should be done at least one excavation per mile. So many of the pipeline operators, have to 2035 to finish that up. Regarding, this is my favorite one, and this is the most ignored one. It's continuing surveillance. It's overlooked, and this is why I bring this up. And I'm going to read this one because I think it's very important. Each operator shall have a procedure for continuing surveillance of its facilities, determine, take appropriate action in the class location, failures, leakage history, corrosion, substantial changes in CP requirements. Back in my day, we kept track of that. I don't see that today. Changes in CP requirements, and we had to justify and find out why there was changes, and unusual operating and maintenance conditions, and even though this was just in the regs, this is something we took seriously years ago, and I hope we're still doing that. The other thing is damage prevention, subpart L. And of course, for the purposes of this section, the term excavation activities includes blasting, and this is a pretty big deal. And we get a lot of queries about our blasting calculations and things of this nature, boring, tunneling, backfilling, and things of this nature. So, and you really need to understand, the explosives and the mechanical means, the wave that comes in, and what's behind it, particularly with vibration equipment and things of this nature. So keep this in mind, particularly when there's blasting operations. Subpart O. The gas regulations have their own subpart, and then the specific regulations that are included. As compared to the liquid, it's combined with their operations section. So what do they cover? Well, of course, it's going to cover the minimum requirements, under this part. But more importantly, what are the elements? High consequence areas, baseline assessment. That needs to be done. That's the first thing that needs to be done. And understand, how you're going to design your system. Identification of threats. 22 threats. Let's not forget about them. All the threats, not just some of them. Continual evaluation. That's why we have risk programs. How do we know something's being done correctly, and being taken care of? Have we reduced the risk? Monitoring, provisions for meeting requirements, mitigation, performance measures, record keeping, and that's TVC, management of change, quality assurance, and a communications plan. The communications plan. This is something I think that has to be really looked at again, because there was a time where I was located in the high consequence areas of the Northeast. They had line patrol every day. The company did. And one of the things they established was great communications with the people who lived around the pipeline. Those people, I could tell you for a fact, kept the eyes and ears open and called the company when they saw things that didn't look right on the right of way. That's how important it is. It's another set of eyes and ears. I could never believe it. Why? It's because those line patrolmen had good communications with those people around who lived around the pipelines. Subpart O. We talked about the high consequence areas, the baseline, the actions, the DA, ECDA, ICDA, SCCDA, and of course, confirmatory direct assessment, where you only have to do one survey once you get the others completed. And then the prevention and mitigation. And where is direct assessment used? Primarily on unpiggable systems, okay? And it detects only the coding anomalies, and then it has to be analyzed to determine if there's any corrosion going on. So it doesn't directly look for corrosion, it looks for coding anomalies. So keep that in mind. Of course, ICDA would be water holdup and things of this nature, and SCC would be similar to the ECDA, but more on the environmental side, to determine particularly where the shielding is occurring on the coating systems. Continual process. It doesn't end. This stuff doesn't end. And the same thing with the risk programs. It has to be done. When they say continual, I say day to day, on a day-to-day basis. And then your reassessment intervals and records. What records? Of course, you got to have your plan, your threat identification, your risk program. I was involved in risk at one time, and like I say, it had to be a day-to-day thing. One of the things when I was involved in risk is I visited every station on the pipeline. Why? So I could get a feel of what their needs were. I went out and asked each one of them questions. I had probably 25 or 30 questions, and I knew all the answers, but it was just to see what they would say and how they perceived it. And it was interesting. Every station said, "We're the best." And that was a good thing. I think that was a good positive thing. However, reality says something different, because one of the questions I asked, I says, when did you guys have your last leak? And nobody could remember. No one. Of course, I had all that information. But these are the kind of things, we have short memories and people change and things happen. And your baseline assessment plan has to be one of the key elements before you could even start integrity. You have to have a DA plan if you're going to use direct assessment, particularly for areas that are unpiggable, like crossover piping and things of this nature, small laterals, etc. And documents to support your decisions, even your telephone calls or team calls. They should be documented. Decisions, analysis, the processes, any deviations from it, implementations and actions and evaluations. Documentation is key. Just have one failure, and you'll find out how quickly you need to understand all of these. And it's a wake-up call. So subpart O, stands by itself compared to the 195. Now which one's better? They're both the same. They have the same goals, but you could see, when a gas line fails, it does do a lot more damage in many cases, strictly by the product. Okay, so let's go to 195, operations and maintenance. Well, guess what? The integrity management portion is in part F. And what are the elements? The elements are all the same. The integrity program begins with the initial framework, what the gas people call the baseline and so on. An operator must continually change the program to reflect, the operating experiences, conclusions, and so on, from the integrity assessments and other maintenance activity and surveillance data and the consequence of failure. They're all basically the same. And so keep that in mind, and that's what you'll see. You'll see 1160, your industry standards, and now to support what the regulations are stating. And then we got subparts, GHL, and so on. But the bottom line is which includes the pipe attribute data, is your hydro test, your ILI, your close intervals, your R string calculations, and they mentioned it in there. Pressure reduction, risk, emergency failure, devices, verification records, notifications, and so on and so forth. So this is what we're looking at. Also, corrosion control has its own section, and so on and so forth. I'm not going to repeat a lot of this stuff, but here we have a flange on top of a vessel here, and as obviously we could see, we got some on the flange faces inside here, and you can see the gasket. You can have, we have corrosion coming out, between the flange faces. This is not a good thing, and also running down through the bolts and everything else. So this is what we're talking about. Not just submerged pipeline, but we're talking about above ground too, offshore and so on and so forth. And then the biggest thing we should be thinking about is the environment. We spend a lot of time on, trying to determine, where the corrosion is. But if we understood the soils, the environment itself, what's, are there power lines in that area, that could impact it with AC interference, but also the corrosive activity. You get some very low soil resistivities, and all of a sudden, you could have both AC and DC corrosion very quickly. And then the mitigation of internal corrosion, CO2 inhibitors, coupons, and so on and so forth. And biocides, of course. So what are we talking about? I'm going to just go through these quickly. What we want to do is identify and analyze the actual potential precursor of events that can result in pipeline incidents. We have to be a detective, but also we have to be a prognosticator in the sense of we need to understand, provide the comprehensive integrated means of examination to compare the risks to the risk reduction activities. And that's why it's important to have that risk program updated literally on a daily basis. It shouldn't be one big data dump, a couple times a year. I got my ILI data, or I got my close interval data, or I got whatever data that came in, or your cracking data. It has to be more than that. That's just the means. And then we need to provide a method and the communications to implement risk reduction. So the people that are in that risk program really need to know what they're dealing with. It isn't just sticking somebody in there and just running some numbers. They need to know what the facilities look like. What are they trying to manage? Understand. Like I said, I knew all 50 of those managers inside out. I met each one. That's how important, but more importantly, not just knowing them, what their facilities had that was different from the next facility. And that played an important role. So when you're sitting in the office, running these programs, it's just not the numbers themselves and the values, it's what's going on locally. Establish and track system performance. This is all part of it, but we need to go more than that. And that's why I bring this out. Okay, so I'm going to run into these, bring them all out. Integrity must be built from the initial planning and design. Yeah, yes. And you quickly find out about how good your data is. That's another thing. Must be flexible. You better believe it better be flexible. Integration of data and information is key. If you don't have that data, and it can't be verified, then the company has a problem. You can't if you can't verify that data, because a lot of times companies buy additional assets and that don't have data. So what do we do? And again, I'm going to emphasize this risk because I helped establish one of the risk programs for the company. I was involved in that, and I was part of the team. And then also, it's a continuous process. It's not once a year we're going to run the program and we'll see what we got. No, it's too late. And mitigative actions for injurious defects. And then, of course, keep up with the technology. I can't say enough on that. And then reevaluate the integrity management programs. And we need to be looking at the HCAs, and not just to the high consequence areas, but also the moderate consequence areas and things of this nature. But we should be looking at the nature of the product, what type of product is being pumped through through the pipelines, and there's some pretty rough products that go through. So operations, pressure, temperature, we got hydraulic gradients, particularly with the liquid lines you have to deal with, and the hammer effect and things of this nature, diameter of the pipe and release volumes, the physical pathways to these HCAs. Just because you dumped it in a little creek doesn't mean it's not going to go into a big river or an area where there's high consequence areas. And then we need to look at the natural forces such as floodplain subsidence, earthquake activity, and other issues. So I can't say enough about that. If we don't take those into consideration, subsidence and the flooding issues, that has really taken a front, moved up to the front is the flooding issues and the response capability. Are we able to detect it in time, not after the fact? Confirm, locate, and respond. Yes, we detect it, but somebody called in and says, "Oh, by the way, this has been leaking for the last week or so, and already I don't know how many barrels of whatever came out." So let's keep that in mind. 1160, again, the data sources, similar to API B31.8 you're dealing with your PI&D, the alignment sheets, aerial, and so on and so forth. GIS, right away, your as-builts, your O&M procedures, inspection, and we shouldn't take this lightly. We should know these requirements inside out because they're your requirements. They're your law. Once it's written down in your procedures, it becomes your law, not the feds or the states. This is your law, and your environmentally sensitive areas, the USA, unusual areas, your topography, and of course GIS plays a big role in that. and the high consequences areas, and then the incident and risk. This is where your special surveys come in, your technical studies, determine, where really are my areas of concern. And of course, TVC stands on top of it. So, 1160, internal, external corrosion, third-party damage, ground movement, which we talked about, whatever it may be, design and materials, which is, and this is common to whether you're a liquid or natural gas or whatever, population, environmental, business interruption. There's a lot of times, on the consequence side, sometimes there's very little we could do. If there's major buildings there and rivers or this or that, they're there. We're not going to move them. There's nothing we could do about population. We can't change the direction of the river because we don't like it. So we have to work, within those issues. And of course, business interruption. You don't want to have that. This unanticipated, leaks in these areas. And the other thing we should be thinking about is the risk assessment. Again, it covers all of these inputs, and one of the things that, again, is keeping up with, all this information. Whenever there's a pipe change out or relocation, things of this nature, we need to consider that. We need to think about, the depth and so on and so forth of the pipe, and public education. I can't say enough about that. Again, I gave you that deal when the company was doing it. They had such a good relationship with the property owners. O&M, leak detection, ILI, hydro, spill plans, temperature, corrosion monitoring, and so on and so forth. This all has to work together, really, as it should be integrated. One of the things I continually find out, and I hear, since I've been away, I retired from a large gas company about 22 years ago. I haven't stopped working since then. Is still I hear the corrosion people don't talk to the integrity people, and vice versa. Why? You guys need to be that, and the risk people are in their own cubicle, so to speak. They don't speak. They don't really get into each other's hair, so to speak. They need to. Risk assessment must be integrated, day-to-day activities. Risk, qualified individuals that understand what's going on and must have a way to evaluate and update, bring up the data. And then data should be complete. Incomplete data results in poor, misleading results. You bet. And then I underline this one. Why? Because data must be regularly prepared and updated and maintained. If you don't do that continually, it isn't a data dump, 2-3 times a year, and we're going to look at the ILI data. No, it's more than that. It's environmental and things of this nature, and I'll get into that in a few minutes. And data can be specific, and the level of importance of weighting must be considered. And let's take a look at this. Your risk variables. Again, they mention environmental risk, soil type, resistivity impacts, current distribution on your systems, type of coatings. We got coatings that shield, such as high dielectric coatings. And where do we get? We get unanticipated damage and leaks. Why? Because it's concentrated. And then we could get SCC underneath those shielding coatings because of the issue with shielding and lack of CP. You can't get the CP through it. and acidity can increase your corrosion rates for internal corrosion. And then diameter makes a difference. Wall thickness, resistance to third-party damage, but more than that, how about the toughness of the pipe? You could have a heavy wall, you know, with a X30 pipe, but it has no resistance. It's subject to cracking when it's hit, no matter how thick it is. Additional ground cover reduces the likelihood of hits. Yes. And what are we getting up and down our pipelines because of the flooding? We're getting erosion, soil erosion. Case crossings help, but now we do HDD. So deeper is not always better sometimes. That's another issue. HDD crossings, another subject, another day. But anyway, we need to look at mitigation, to prevent, controlling, preventing third party. How do we do it? Who's minding the store? Controlling corrosion, detecting unattended releases, minimizing consequences. Maybe we have to reduce the pressure. Improvements, what can we do? What's our risk control options? Modifications, more testing, maintenance activities, repair, replace, renew, personnel training, leak detection, emergency response, and so on. And keeping that communications up with the public and regulatory agencies, and of course reassessment. And here's your reassessment factors. I highlighted this one, the rate of degradation of corrosion rates. Everybody goes with that. Oh yeah, we got a corrosion rate of 2 or 3 mils per year. Well, what about the number of repairs? What about the leaks? What about the causes? What about the potential consequences? What about the quality? What about like similar analysis in other segments or sections of the pipe? What's going on here? Change in service or operating? Are we keeping up with, what's happening on the pipeline? It's not just the rate of degradation. Why are we even experiencing it? We need to look at these things. That's all part of reassessment, not just take one number. Okay, we got our corrosion rate. We know what's going on. Not enough. Okay, so we got a baseline plan, and we got. So we talked about the baseline plan, initial gathering, the factors. We get the pipeline anomalies, the various. With the ILI and hydrostatic or DA data, pipeline repair, anomalies, defects must be analyzed. Who gets out in the field and really looks at these defects and understands them? How many people get out of the office and really understand what's going on? And then the tools and techniques. And we're gonna talk about AMP and NACE a little bit later, okay? So we could bring this in. All right, so this is why I bring up a lot of these things, okay? The framework, gathering, reviewing, integrating data. But it's more than a framework, it's the people. It's how it's integrated, the tools, the mitigation. Do we have, is it working like all the gears are turning all in the same direction? The program evaluation, the communications plan, your management of change, does it really work? Does it go up, not just up and down the hierarchy, but across the company? Integrity management plan, quality control assurance, is that really happening? I wrote, like I said, I wrote a paper, Who's Minding the Store? Okay, so what is the goal? We have great goals. It must be comprehensive, systematic, and integrated. Is it really integrated? Prescriptive process must provide all inspection and detection and mitigation. Yeah, yeah, we could check the box on this kind of stuff. But what about the performance-based? Utilizes more extensive risk analysis. Who's handling that risk program? Do they really understand, you know, how the world works in that company? And then you got to have SMEs. That's what I'm talking about. Subject matter experts that have some experience, that truly understand what's going on. Okay, so we got guiding principles. The implant shall be built into new pipeline systems. That includes the planning, design, and construction. It's too late if it wasn't included. In other words, feedback needs to come back from the field. Are we using the right coatings? I know one company is trying something different. They're using a two-layer coating now instead of just plain FBE. They're trying it out. That has been my biggest complaint in the industry is we haven't kept up with the coatings as compared to the higher strength steels that we've been using, the X70s or X80s or even X100s. The coating systems haven't kept up because they're the same mill thickness that goes on. We got now most new pipelines are in a corridor with power lines. We're sharing the same right of way. Are we thinking about that when we build that pipeline? Integrity management is continually evolving. Information integration is the key component. Integration. You know, I heard that word back in when the integrity rule came out in 2003, and we're still not truly integrated. Maybe AI will begin to bring it in together. This we need to start moving on that. You know, that can look at all of the factors, and bring this data in. Of course, again, risk. Don't minimize risk. And assessing risk to the pipeline integrity is a continuous, and then I just changed this morning and say daily process. I'm sorry, I feel that strongly about it because I was involved in it and I know what it took. New technology should be evaluated and implemented anytime. You know, there could be a cost savings. We should be looking at that. The pipeline industry is a little bit stodgy in a sense of not moving ahead sometimes. This is just a plan. I just took this out of a document, but this is the kind of thing we need, something like this, that has it all in here. And how's it going to be done? This is just a format. We need to go beyond that. So let's think about it. Threat identification. 22 threats. Which ones are we after? Gathering, viewing, and integrating data. What about the risk? Is the risk program, is it detecting, what threat or threats that need to be looked at? Are they evaluated? We need to identify the potential impact by the threat, and so on and so forth. Then we could do our integrity assessment, and then we need to be looking at responses, mitigation. It needs to be a fully integrated process with all the wheels turning, with this threat identification. Do we really understand the threat or threats? We get these unanticipated events that occur, and this becomes a problem. I got to watch my time. So integrity assessment overview. This is the typical thing. Screening. You got your immediates. Got to be done now. Scheduled, monitored. You do your direct exams. Do your R-string calcs. Do your defects. And then determine what type of defects they are, whether they're time dependent, like corrosion and things of this nature. Okay, stable and then time independent. means they are unanticipated. We got our class location, potential impacts, areas. I'm not going to get into this, but we all know about the schools, hospitals, and child care centers, retirement communities, so on and so forth. Your measurement and so on and so forth was based on the 30-inch pipe at 1,000 psi. Again, very similar to what 1160 had, communication necessary to ensure the appropriate individuals have the and authorities have the information about operator system and their integrity, and then what appropriate personnel are involved, and so on and so forth, internal. And then we need to be looking at the management of change, MOC, reasons for the change, and so on. So the authority, the analysis of the implications, the acquisition of permits, documentation, TVC, traceable, verifiable, complete, communications of change to affected parties, time limitations, and again, SMEs, qualification of staff, performance measures, metrics, how many leaks have we had, incidents, number of miles of pipeline inspected versus program requirements, number of scheduled repairs, and then of course the number of immediate repairs. This is all part of the program. So we kind of reversed ordered it, but I just wanted to show you what we should be thinking about. And immediate is like immediate. We need to look at performance measures, the processes lagging and leading. I'm not going to get into this, but but we need to be looking at, hopefully it's not leaks per mile and so on and so forth, but we need to get beyond that. Okay, and here's some of the stuff we need to look at is the preventing, controlling, detecting, minimizing, and then last but not least is pressure reduction. Here's some of the performance metrics. Again, you could use this as a guidance. I'm not going to get into the specifics of it, but I just wanted to get into NACE. Oh, let's go back here. SPO 0102. This is ILI because everybody does ILI. Okay, at least they should be doing it. And of course, you need to look at that document, the standard practice 0102. They just come out with another document, regarding and even the old document had integrity management, but now they come out with a new one, pipeline integrity management methods, selection, and implementation. It's called SP 0113. This SP provides the guidance for selecting and implementing your pipeline integrity management methods, technologies, and processes. So here's another tool in the toolbox, okay, to assess, mitigate threats to pipeline integrity. So we should take a look at this. These are the kind of things we need to be looking at. I'm going to strictly stick with these guys, the 1102, the 0102. That's the month and the year it came out, in case anybody's wondering. Correlation, correlation of the ILI results using R-string after removal, and so on and so forth. After sufficient sampling of soils, pipe environment, mag particle for cracking should be conducted. This is, AUT, automated UT, shear wave, and other non-destructive techniques may be required. And of course, photo documentation, not if required, will be required. I don't like that word if. They have it in there. So that's a minimum. And here's your your excavation data. We should be looking at coatings. How do we get, it was like the Columbia disaster, the shuttle, the tiles. We should be looking at the coating. We should be looking, what's going on and what's behind it, the history. any existing construction and CP data. It isn't just measuring the metal loss. We need to be looking, how do we do a root cause? Starts here, coating, starts with the soils. As long as that coating doesn't fail and you don't have aggressive soils, no problem. Unfortunately, we don't understand that until it fails. We should be looking at pipe modifications, repairs, and other operational issues. This is SPO 02. And I want to keep in line with our folks here, to keep it to 45 minutes. So we're coming to right into conclusions. So I'll spend a little time here. So we should be managing the integrity, of the pipeline system is the primary goal. We got that. It should be comprehensive, systematic, and integrated. Focus on integrated. I think we got the comprehensive and all that other stuff, but are we truly integrated? Are we talking to each other internally and externally? That's the key. And then the other one is performance-based integrity management program, utilizes data and more extensive risk analysis. Again, risk. That's where it happens. We're talking about dynamic data, that's your ILI data, and static data, that's your attribute data, of your pipelines. That usually doesn't change unless you do a relocation or a change out or something. And that enables the operator to achieve a greater degree of flexibility to meet or exceed the requirements of the regulations. Sorry I rushed a little bit, folks, but I appreciate you attending. I'd like to thank you very much. And now I'll turn it over to our staff.